All right, so here we are at the vertical mill. What we're going to do here is go over, I'm going to give you a quick demo on what the vertical mill is all about. Real basic, all right, hopefully not too long. We're going to look at, first we're going to look at some parts of the mill. I'm not going to go over all the parts of the mill, just like the lathe. There are a couple things that I want you to know, and so let's do that real quick, and then we'll put a cutter in, and we'll start cutting. Before I do, typically I want you to know that often, traditionally in machine shop, when they teach machine shop, they go over the tooling first. And I don't do that. Actually, I do it the other way, because I think that by seeing the mill in action or the lathe in action, you have when I show you different types of tooling, which is the next lecture / demo, we're gonna have a better understanding of what all that tooling can do. All right. So let's go over some basic. I'm not going to go over the parts, like I said, like all the parts, but there are some things I want you to know. And the other thing I got to point out is, and we'll talk definitely much more about this in a minute, this mill is hydraulic. So actually to use it, I have to turn it on, and it's got a hydraulic pump. So I'm going to apologize. It's not going to be, I don't think, too noisy, but it's going to be, there's going to be some noise in the background. All right. All right. But I can do some stuff before I turn it on. So let's see. The mill. Let's start at the table. So currently, right now, I've got a vise mounted to the table. All right. The table will move in 3 axes. I mean, we kind of talked about this already. The tool, right, is right here. So here, just grab. All right. So the tool comes out of the spindle right here. Okay, and the tool spins. Okay, and the spindle, or also known as the quill, hang on, will move up and down. So let me do that. This is the quill lock right here. So in this position it's locked, and undone. The quill will move up and down. See that? Okay. And then the table itself, with this handle right here, okay, a little hard to do. This handle right here, this is called the knee. Okay, and it'll move the table up and down. Okay. This handle right here, this is the y-axis, so it's gonna move the table. See that? Along y. Okay. And then this handle over here is going to move the table along x. Okay. So there are, well, I guess you could say 3.5 kind of, I guess it's 4, but I'm going to say 3.5 axes of movement. All right. So the mills that you are going to be using, say in our makerspace, or actually it is, I think it is the most popular type of mill. It's called a Bridgeport. So for those of you who are really into this class or really into machining, you might not be into the class and you might be like machining, the Bridgeport, although does the same, all the same motions, all the same cutting features, it has a different methods of holding the tool into the spindle here. Okay. The Bridgeport has what's known as a drawbar, and if you're interested in this stuff and you look up a Bridgeport and drawbar, you can look on. I mean, come on, you guys can look up on YouTube and figure all this stuff out on your own. But it is nice to have someone experienced show it to you. This particular machine is not a Bridgeport machine. By the way, Bridgeport is a lot like saying crescent wrench. So that's not actually, that type of wrench is not a crescent wrench. It's an adjustable jaw wrench. I don't think I've mentioned that back when we talked about hand tools. Bridgeport is the manufacturer of what's known as a J head type mill, and they get that term J from, if you look from the side, it kind of looks like a J. Okay, this particular vertical mill is a J type vertical mill, but it's made by a manufacturer named Cincinnati. Now they are no longer in business, but I'm going to just tell you straight up. This particular mill is probably the best mill I've ever worked on. Yeah, I've worked on some other ones too that have been pretty cool, like some Lagoons. But there's just something about this mill, and it's just really stout. I mean, I do have some complaints, like I don't have enough Y travel, but it's really stout. It's really just a beautiful machine to use. It's from the 60s, late 60s, I believe. And we're going to see shortly, it has power feeds on all the axes, which is really neat. Okay, so we don't have to crank levers all the time. So we're going to go back down to where some handles and cranks are, and I wanted to show you that this, I showed you, is the Y movement. This lever right here is how fast we control the power feed. Remember the chart on the lathe, you put the lathe in a certain row or column to control how fast the power feed's going? Well, this is that chart here. And there are some numbers on here. They're just covered in grease, and it's been that old. It's that old of a machine. This is the power feed lever for Y, okay? This is the power feed lever for the Z axis, or the knee, okay? This is the power feed lever right here for X. Okay, and this is the rapid arm, and that's about it. Rapid meaning I'm going to move it really fast, which you'll see shortly. Okay, up top here, this is how I control the spindle speed. So when the machine's on, I can adjust this. Okay, let's see here. Ignore this, and all vertical mills have this unless they've been removed. This is what's called a worm, or a worm drive, and what that does is it's the power feed to send the quill down. So if I wanted to drill 100 holes, I might want to use this, but I typically don't, and you typically won't either. Here is another depth stop, like on the drill press. Remember I showed you that, and you kind of know how I feel about that. They're not that accurate. I mean, it's kind of nice. If I want to drill just like roughly a 1-inch hole, there's 1 inch. I can just bring this arrow down to 1 inch. That's kind of nice. And then this is the on and off right here. And it says, this I kind of like. This, it says L and R. Remember before it was forward or reverse, which I don't like? I like this. This is left-hand cutting and right-hand cutting, okay? And then don't worry about this right now. That's for the, you'll see that in a minute. That's how to lock the spindle. This is to put it in high, neutral, or low. So that is going to put us in 2 different settings for our spindle speed. So we can go low, which will be really slow. Neutral, which will disengage the spindle from the CVT, or the variable drive unit up here. And all together, so that's neutral, and then high would be high speed. Okay, currently I'm in high. I'm running at about let's see here, I think I'm running at about 1200 RPM roughly. Okay, I know you can't see those numbers. I can barely see those numbers, but that's where we're running. Oh, and this lever right here that moves both directions is the brake. So after when I turn the machine off, I don't have to wait for it to spool down. I can just lock this brake. So first thing I want to do is I want to show you how to put a tool in the spindle, and we're just going to do some real simple cutting, okay? I think I'm going to show you two types of cutters, and here's my kind of like, I guess you'd call it my station. It's my bench. Lots of drill bits that I use regularly. I do, here are my calipers, a drill chuck, some wrenches, a file. This is the wrench to change the collet or the tool in the mill. These are the different collets that will hold some tools, okay? And then I have a wide selection of parallels right here, some cutters, some clamps over here, and they are for clamping stuff to the table. My calculator, if I don't always like to use my phone because it gets you know, my hands are filthy, and so so hopefully over the course of the semester this will look similar, messier, cleaner, in between, and we'll be making parts, okay? And some, you know what these are now. These are taps. You know what these are center drills, and some cutters, and you know what this is. This is a reamer, and let's see, so it's a 498 thousandths, so it's 2 thousandths under half of an inch. Wonder what I was doing. Probably making something that I needed to press in. I don't even remember, to tell you the truth. There's a extra long, fancy carbide cutter, a countersink, and yeah, okay. This, if you're wondering, it's more of my scrap metal. This is a leftover part, and what I do with this is I use this to find center of a circle on the mill, and then I can zero out the mill, and I have a center of a circle. And this is just something that I know is round and perfectly concentric. The actual size I don't really care about. I just know that this is round, and this hole in here, this hole in here is perfectly concentric, okay? Real quick, if we move over here, I've got more cutters, lots of carbide. Here's my fancy drawer of carbide cutters. I use these for the CNC machine and other types of stuff. That's what's going on here. My mics, the kind of that stuff. This is sort of a backup drawer. Okay, this isn't the main drawer. So yeah, used carbides that are still great. These are my back. These are all my taps. Some extra parallels. This is for you guys. These are all the center drills that I buy by the 50 by 50. This is my let's look at this. This is cool. Let's see if you can see that. This is my rocket stamp. A student gave me this a while back, and I stamp fancy parts with it. So if someone tries to steal them, the rocket is hidden, and haha, I've got you. Okay, enough screwing around. Let's go to it. Let's put a tool in here. All right. So what I'm going to do is unscrew this. Okay, and let's use this my phone to make sure I'm getting all this. Let's use this cutter, and looks to me like 5/8 there. Okay, so we're going to put the collet in here. Collet in here like this. It just sort of snaps in. Okay, and put this in the, screw this in, not too tight. All right, and put the cutter in, and you can see here that I'm not going to grab it by the flutes, okay? I'm going to grab it just like a drill bit. I'm going to grab it by the shank, okay? And then Remember I showed you in a minute that I was going to show you that what this does up here is it locks the spindle. There it goes. And what else it does is it locks I can't turn it on or off with this engaged, okay? I can only, it locks the spindle. Now I can take my collet wrench, and I'm not cranking on it, but I'm just going to tighten up the collet, and now I can unlock the spindle. Okay, so now I've got a tool in the cutter. Next lecture, I'm gonna finally give you the formula for the spindle speeds. But right now, I don't want you to worry about that. I just want you to pay attention to the philosophy here. Okay, not yet. I want you to just know the philosophy about what's going on, like way that the mill works. That's it. I'm not even so concerned during this remote learning business about, really you guys knowing how to put the tool in the cutter. I mean, you're not going to be able to do it. You're not going to understand until you do it. Of course you'll be able to understand, but you'll never get it until you actually do it. So let's not even worry about that, right? I mean, if you really want to know, email me and I will be delighted to show you. Okay, so I'm going to do something here. I think that some people will be like, he's doing it wrong. He's doing it wrong. And you know what? I care, but this is the way I'm going to do it. All right. Textbook is going to tell you to use 2 parallels. All right. Oh shoot, I forgot something. Okay, the textbook is going to tell you that you need to use 2 parallels. What are parallels? Parallels are what we use to these are parallels, and they're what we use to bring our material up off of the table, okay, or the vise. These are parallels. They're hardened steel, okay, and they are ground, so they are perfectly. They're exactly the pairs are the 2 pairs are exactly the same height, okay, and not just in height this way, but if I were to lay them flat like this as well, they are exactly the same height. So the textbook is going to tell you to put 2 parallels in your vise. All right, not these are large. I believe that's what the textbook says. I could be mistaken on that. I'm going to use 1. Okay, and you always put parallels in the vise to elevate your material. Okay, so I put it in here. I got this. It's an aluminum rod. It's for squaring a block. We're not going to do that today. I just changed my mind. We're not going to do that. We're just going to look at the mill. All right. And what I'm going to do is I'm going to move the Y handle here and bring it out from underneath the. Okay. And I have this is a dead blow hammer. And what I'm going to do, the way I'm going to get my material in here, okay, is I have, what I did is I put my material in, okay, and then with the vise handle, I just made it so I didn't tighten it, I didn't even snug it up, I just touched it so it wouldn't move around, okay, and now very lightly, I'm just going to tighten and tap at the same time, okay? If you're slamming on it, you don't want to do that, and if you're cranking on the vise, you don't want to do that either. I'm barely just making sure that that's down on the parallel, okay? And then I'm going to remove the vise handle. Okay. All right. So I've got material in the vise supported on a parallel. And you can tell that it's all squared away and nice because this isn't chattering around and it's barely even moving, okay? All right. So now I guess I have to turn on the machine and I will demonstrate how this machine works. And I think I'm just gonna talk and cut, okay? And yeah, I think that's what we're gonna do here. So let me turn it on. Yeah, it's gonna get noisy. Okay. What that noise is the hydraulic pump. And so let me demonstrate here. So by turning this, okay, and well, you can see the table is going to move automatically, okay? This machine's really awesome. There, it's moving. I got it in moving up on the knee or the Z. It can come back here. All right. Yeah, I guess you could say I'm a little bit spoiled. This is pretty cool. So I said that the cutter is in about 1200, which is actually pretty close for aluminum. Okay, that's actually close. I'm not even going to do the calculations, but I just know from doing this for so long that's pretty close. So there we are. I turned it on. Okay, turned it off, and there's the brake, and yeah, there's the brake. Let me do that again. Turn it off. There's the brake. Okay. So let's check this out. And I'm just gonna do what I normally do on the lathe too. We're not gonna go. Yes, we are gonna go to the thousandths place, but let's just get an idea about how this works. And so what I'm gonna do is I'm gonna not use the power feed. And I'm going to do it all by turning the handles. I'm going to touch off, okay? I'm not going to measure. Just going to give you an idea about how the mill works, okay? Real briefly here, okay? So let's go ahead and turn it on, and I'm going to crank up. So what I'm doing is I'm going over to the corner. All right, there I'm at the corner, okay. And yeah, I got my glasses on, of course. And what you don't want to try, what you want to avoid, and sometimes it's impossible, is doing what they call a full face mill, meaning I've got the entire 5/8 of an inch diameter going like right through the middle. Now if I wanted to cut a slot or something like that, obviously I'm gonna have to do that, okay? But you want to avoid that as much as you can. It decreases the life of the cutter, generates a lot of heat. But so I'm gonna use half of the face, okay? And so if you're wondering why I'm only using half of the face, that's why I'm using half of the face, okay? So I'm just going to touch off a little bit here, and I'm listening more than anything. Okay, there I hit it, okay? And I'm going to back the tool off the material there. I think you can see that. And now what I'm going to do is I'm going to raise the table, not lower the cutter. I'm going to raise the table. You know, maybe 30 thousandths. Okay, so I did 40 thousandths. Okay, we're not, like I said, we're not even shooting for anything here. Okay, and that's my feed rate. I don't have the power feed on. I am doing this manually. Okay. They come all the way off the part. I moved Y in a little bit. Now, if you got any experience doing this, you're like, oh man, you could be taking a bigger cut. Hey, look, this is an introductory class. I'm showing you how this stuff works. Yes, I can be taking a much bigger cut. Actually, there's all kinds of things I could be doing. So, you know, you can keep those comments to yourself. All right. Okay, so now what I think I'm going to do, just because I feel like it, is I'm going to put a little step in here. So I'm just going to what I'm going to do is I'm going to machine in a little step like that. All right? Because I can. So I'm going to raise the table about 50 thousandths. Where are we here? There we go. Okay. About 50 thousandths. Okay. And I want you to really pay attention to my feed rate. If it was steel, I would need to go slower, okay? And if it was steel, my tool would be going slower as well. Okay. So what I'm going to do to mark my Y location is I'm going to put my dial on 0. Okay, so my dial is on 0. Now I know where my Y location is. So as I go to the next pass, which you'll see, I'll be able to get right up against that wall. Okay, so that's my 0 for Y, and we don't need a 0 for X. Obviously, we're going off the part. Okay, so I'm going to go another 50 thousandths. Oh, look at that full face right there. That's all right. Let's do it anyway. Notice how I'm going much slower now. So with that full face cut, I slowed down my feed rate. I probably halved it. But we don't know exactly what it is, so. But I really did. I mean, I really slowed down my feed rate on that full face cut. Okay, so that was a full face cut. Okay, and let's not do that again. I mean, we can. It's fine. But like I said, we want to avoid it. I don't know. Let's do. There's another 50 thousandths. In case you were wondering. My dial on my Z is 1 revolution is an 1/8. Actually, hold on to that thought. I'll talk about that later. I'll bring this over. So I'm going to bring this over to my 0. Okay. more pass. That's it. We'll do another 50. Okay, back to zero here. Make sure you can see that. Back to zero. All right, and now we'll do a last pass here. See how this does. Yeah, there we go. Turn off the machine, even though I normally wouldn't. I normally wouldn't turn off the machine when I'm just working, okay? But since it's so loud and we're on camera and stuff, I'm gonna turn it off so I can talk and not have to yell. Okay. So, you know, and we could have done the same type of operation in Y, you know, in Y as well. So once again, X, okay? And Y. I want to just take a moment. I'm going to switch cutters, but I want to take a moment and I want to talk about the dials on the machine. I think that I wasn't very clear when we first started this, and I want to take a look at those dials so you can see what's going on there. I think we'll use the X dial first. It's the one with the most light, okay? So, just to autofocus there, I think, yeah. Okay, so each tick on the dial is 1/1000th of an inch, all right? Now, this particular machine, this has, if you can, there, I put it on zero, lined up with the zero, okay? If you see it before, it says 240. Well, guess what? 240 plus 10 ticks is 250. 250 thousandths is what? 1/4 of an inch, okay? So this particular dial, and same with Y, is for one whole revolution, it will turn 1/4 of an inch, okay? Now you can get any ratio you want, okay? But most mills that I've worked on, like Bridgeport's, they're on 100,000 dial. They're on 100,000 scale, okay? This particular lays on 1/4 inch. Personally, I kind of like it. And I like, because I work in standard. I like working in that. I know you can, 100,000 is 1/10. I realize that. But I like this. And it just took a little bit to get used to, and I actually really like it. I don't know why, but it just made a lot of sense after a while. I know I'm kind of going off here, but so the Z or the knee handle, right? You can see 120, and I have it on zero, but you can see 120. Well, 120 plus 5 ticks is 0.125. Well, what's that? That's 1/8. So this for every 1 revolution on the knee, it will turn 1/8 of an inch, up or down. Here is the Y, and it's 250. It's 1/4 of an inch. Okay, and for those of you who are like, okay, well, how do I use it? Well, don't worry. We'll get there. Some of you might have figured it out a little bit already, or looked something up, or had done it, or something like that. But don't worry about it, okay? All right. Let me let's see here. Let me take out the part, and we're going to change tools. It's back on. Sorry, I know, but it's the only way I can have 2 hands free. Otherwise, it's just really difficult. I've tried a lot of things. Okay. What I really need is a camera operator. And man, I would love to have one of you volunteer for that, but you can't do that. That would be, can't do that. But I would love a camera operator, let me tell you. So, it's critical that whenever you take something out of the vise, you have to wipe all the chips out of the vise, and you have to wipe your parallels too. Why? Okay, well, if one of these chips is in there, okay, and you put your parallel down on, I'll do it right here, on one of these chips, is that flat? It's cocked now, okay? It's all right. So it's absolutely imperative that you take a rag or a brush and you clean out those chips, okay? You must do that. I'm not going to use a deburring tool on purpose, okay? But I do want to just show you. Remember we talked about filing? And I'm going to show you the right way to file really quick, okay? It's actually super simple. You just need for someone to show you. What I'm not going to do is that, okay? What I'm going to do is I'm going to hold the file kind of like this. I might adjust my finger a little bit. I might hold it back like a normal, right? But typically I'm going to hold it like this. I'm not going to white knuckle it. I'm just the guide, okay? And so check this out. All I'm going to do, see that? The whole, all on the push, okay? And look, all right? You can see that mess I made from doing, right? You can see it in the light, right? Okay? Oh, that's all I'm going to do. Okay, I'll do it on this side, this corner here, okay? That's it, all right? Okay, that's how to file or deburr a part real quick. So what I'm going to do, I'm put this back in, okay? Put this back in on a new face. All right, not moving. And I'm going to change tools. So let's get this vise out of the way, okay? And I'm going to, yeah, I know, lock that pin. Remember here? I'm going to lock that pin so this won't go. And I'm just going to loosen this gland nut. Okay, and it popped. The collet freed itself. And I'm going to take this out. And the other tool that I am going to be using is the other thing, I might as well just get this out of the way now. You're going to see me, and I'm not going to be able to break this habit, even though I should for the videos and for this class. But I can just guarantee you that it's a habit that I'm not going to be able to break. It's not a good habit, it's a bad habit. But you're going to constantly see me do things like spin this in my hand, okay? You're going to see me put my thumb in here and clean this out, okay? Or do just you're going to constantly be seeing me do that, okay? Now, I don't want you guys to get in the habit of doing that. I put the collet in, I'm putting it back in the spindle. Because actually what I'm doing is I'm making sure that there aren't any chips in those tapers. So if we look at these collets along this taper, the taper, believe it or not, is what's doing all the work. Tapers are an amazing thing. They're what holds your car together when you're going down the freeway at 90 miles an hour, believe it or not. The pins and the keys, yeah, they work, but especially on machines, what does the work are these tapers, okay? The tapers are what's holding the tool from just spinning in there. Not any, even though this doesn't even have any keys in it, You'll see like the Bridgeport definitely does have keys on their collets, okay? And then they have a taper. I'm not going to get into what the keys are there for. They're there to help you get the tool in and out, actually. But what's doing the work is the tapers, not the keys. So if there's any other machinist out there, maybe I helped you out a little bit just there. Okay. Okay, so what I'm going to do, this fancy looking tool with this indexable carbide, this carbide insert in here, okay, this is called a fly cutter. Now, fly cutter, do you see that? Do you see that? Yeah, I think you can see that now. Right? It's held in this, okay? All right. We're going to go over this next lecture. So, look at that. Put this in the spindle, the fly cutter, okay? And the fly cutter is definitely not for an operation like I just did, cutting that groove or that shelf in that part. The fly cutter is for surfacing. So you're going to take light cuts, very light cuts, and it's going to make your the surface of your material look really smooth. I know there's a couple people in the class that are into cars, so they, in like the old days, definitely, probably up until and they still do it actually, they use fly cutters to surface your cylinder heads, or even surface the top of the block where the cylinder head will go, mounts to. Any type of flat surface where a gasket is going to, two mating flat surfaces where there's a gasket in between them, all right? Those surfaces have been fly cut. There's other techniques to do that. So for the people out there, they're like, nah, they don't do that anymore. Yeah, I know, okay, yeah, I know. But we're trying to get the point across here about what these tools do and what this equipment does. Okay, so I'm just going to demonstrate the fly cutter real quick. The feeds and the speeds rules, they have their own sets of rules. So I'm going to actually lower the speed a little bit. I'm going to bring it down to about 1,000. It's at 1,200 right now. After I turn on the machine, and then I'm going to use the touch-off method again. I will show you a very accurate way to find the top or an edge of your material, and I'll also show you I'm the broke machinist and dirty way of doing it, but yet it's super accurate, okay? And you can impress people in the future, hopefully, with that. So before I even turn it on, to avoid some noise, I'm going to get this close. I'm cranking Z up, okay? The cutter, I think it looks to me like about 1/16 of an inch off the material, all right? So I'm going to go ahead and turn the machine on. I'm going to touch off, and I'm just going to make a few passes. And of course, I'll be yelling over the machine while I'm doing it. Okay. Here we go. So machine's on. I'm going to turn the spindle on, and I'm going to roll back the RPM a little bit. I'm going to roll back the spindle speed to roughly 1,000, okay? And you can hear it go down. So that's about 1,000 RPM. And I'm just going to center this, eyeball center it, okay? And let's touch off. And I'm listening. As much as I'm watching, I'm listening for that touch off. Remember, I was about 1/16 of an inch away. There. Hear that? That tick, 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 tick? Okay. Now I'm just gonna bring this, I'm gonna bring this off the part, and I'm gonna raise it about 10 thousandths. All right? And now my feed rate is gonna be much slower than what I was doing before. So there we go. I take the back side all the way off as well. Okay. Ooh, that's pretty. That's nice. I think for this last cut, I'm going to use the power feed, but I'm going to make the table go this way first, so I can adjust the speed of the power feed, okay? So I'm just going to slow that down a little bit. Whoop, wrong way. Yeah, that looks good. Okay, so I'm going to take another 10 thousandths. And there's 10 thousandths. I'll get in here close so you can see. So we want to do the back side too, okay? And this is with the power feed, so I'm gonna turn the power feed off now. Okay, I'm off the part, so I'll turn the power feed off. I'm gonna turn off the machine. Okay, now I'm going to turn it off because I don't want to yell over the pump. All right. So, all right. That's pretty good actually. Could probably touch up my cutter a little bit and I get a real mirror cut. But if you were paying close attention, when it was coming after the front edge was coming off the part and the back edge started to come on, you could barely see it cutting, and then as the tool was going this way the first time, and then it was going the other way, and you could barely see it cutting, and it was about even. Okay. So I spent some time adjusting this machine to make sure that my spindle is pretty vertical. I think I'm within a thou on my. It's called tramming, TRAM. We're not going to get into that in this class, okay? But you will often come up to a machine and it will cut on the back side, on the back of the front's already done in the back, and it'll cut on the back side more than it cuts on the front side, and then it go the other direction and it won't cut on the back side at all, okay? The reason for that is that the head is out of alignment. I'll take a minute and I'll show you a couple things, but I didn't want to overwhelm you when we were going over the mill, and I knew I was going to talk about this, so I saved it. So the head on a vertical mill will rotate, okay? It'll rotate this way a little bit past 45, although I don't think I've ever done that before in my entire life, and it'll rotate this way, say to 45, okay? The head will also rotate this way out, all right? And it's mounted on a turret, and it'll move in and out too, okay? So you can adjust the head. So if you can imagine, when we have a cutter in here, sorry, I'm trying to make sure you see this. When we have a cutter in here, I can rotate the head, right? So I could mill in 45s, I could have a compound angle, right? It could be like that. Or I could even drill in, right, at a compound angle. Or I could drill in, okay, so the head will move. But when you're fly cutting and you see that it's cutting more on the back side than on the other, then your head's out of alignment, all right? So I think that's kind of cool. It was very, very simple on the vertical mill. We are going to be making stuff on it. So, and as we go, I think that's a better way to learn about these machines, and we'll learn as we make stuff, as opposed to me just going over this kind of stuff. I'm getting bored going over this stuff. I want to make stuff. I really am. And I would imagine that if I'm getting bored, you guys must be like, oh my God, not again. So I'm gonna ditch some of the ways I've been doing this, and we're gonna start making stuff. I do have a couple more lectures though that I know. Come on, man. No, I do want to do that, but they're definitely gonna be mixed in with some demos. All right, so until next week, awesome.